Welcome to a webcast produced by the Learning Enhancement team based in the Dean of Students office at the University of East Anglia. This webcast is part of the Steps into Algebra series and concerns quadratic functions. This guide introduces the general form of a quadratic function and also describes their corresponding graphs. Introduction. Every quadratic function takes the form y equals ax squared plus bx plus c, where a, b and c are numbers called coefficients and x is a variable. The coefficient a can take any positive or negative value except for 0. b and c can take any value at all. The graph of every quadratic function is a curve called a parabola. A parabola is a special symmetrical curve which is one of the conic sections, i.e. it is formed by cutting a cone in a specific way. For example, y equals x squared plus 3x plus 2 and y equals minus x squared plus 3x plus 2 are quadratic functions with their corresponding graphs given below. This is the graph of y equals x squared plus 3x plus 2. Here, a equals 1, b equals 3 and c equals 2. This is the graph of y equals minus x squared plus 3x plus 2. Here, a equals minus 1, b equals 3 and c equals 2. The effect of different values of a, b and c. Different values of a, b and c in the general quadratic function control the positioning and steepness of the corresponding graph. The effect of a. If a is positive, the graph is a valley shape. If a is negative, it is a hill shape. The larger the magnitude of a, then the steeper the graph. The value of b. The value of minus b divided by 2a controls the axis of symmetry of the parabola. The axis of symmetry is the mirror plane of the graph and moves the graph left and right dependent on the values of a and b. The value of b alone controls the slope of the graph as it crosses the y-axis. Values of c. Increasing values of c move the graph up and decreasing values of c move the graph down. Significant points on a parabola. There are some points on the graph of a quadratic function which have a particular significance. The position of these points can be determined using algebra. Point 1. The y-intercept. A quadratic function always crosses the y-axis. At each point on the y-axis, the value of x is 0. So, the y-axis is the line x equals 0. Because of this, the value of the y-intercept can be calculated by setting x equal to 0 in the quadratic function and is always equal to the value of c. Let's look at an example. Where does the quadratic function y equals x squared plus 3x plus 2 cross the y-axis? As the function crosses the y-axis when x equals 0, by setting x equals 0 in the function, you find y equals x squared plus 3x plus 2 equals 0 squared plus 3 times 0 plus 2, which equals 2. So the function y equals x squared plus 3x plus 2 crosses the y-axis at y equals 2, which is also the value of c. This is shown explicitly on the graph previously. 2. The x-intercepts. The two graphs shown previously are quadratic functions which cross the x-axis at 2 points, but it is not always true that a quadratic function cuts the x-axis. For example, y equals x squared plus 2x plus 1 just touches the x-axis as a single point. This is a graph of y equals x squared plus 2x plus 1, which just touches the x-axis at x equals minus 1. And the function y equals x squared plus 2 does not cross the x-axis at all, as this graph shows. For quadratic functions which cut or touch the x-axis, the relevant points can be found by setting y equals to 0 and solving the resulting quadratic equation. The solutions of the quadratic equation are known as the roots. If a quadratic function does not cross the x-axis, then the roots are not real numbers, but complex numbers instead. There are a variety of ways of finding the roots of a quadratic equation. See the study guides: solving quadratic equations by factorisation, solving quadratic equations using the quadratic formula, and completing the square. 3. The point at which the graph changes direction. This point is called either the stationary point or the turning point of the graph. There is a straightforward way of determining the position of the turning point if you know the quadratic function. The x-coordinate of the turning point is the value that controls the axis of symmetry of the parabola and is given by minus b divided by 2a. The corresponding y-coordinate can be found by substituting the value of x equals minus b divided by 2a into the original quadratic function. If the parabola touches the x-axis at a single point, this point is also the turning point. If the parabola cuts the x-axis, the x-coordinate of the stationary point is halfway between the two cut points, as the parabola is symmetrical. If the parabola does not cut the x-axis, the x-coordinate of the turning point is halfway between the two complex roots. Let's look at an example. Given that the quadratic function y equals x squared minus 6x plus 8 cuts the x-axis at x equals 2 and x equals 4, find its turning point. As a equals 1 and b equals minus 6, the value of the x-coordinate of the turning point is given by minus b divided by 2a equals minus 6 divided by 2 multiplied by 1, which equals 6 divided by 2, which is 3, which is also halfway between the cut points of x equals 2 and x equals 4. The y-coordinate is found by substituting x equals 3 into the function y equals x squared minus 6x plus 8. So, y equals x squared minus 6x plus 8 equals 3 squared minus 6 times 3 plus 8, which equals 9 minus 18 plus 8, which equals minus 1. Hence the turning point is located at the coordinate 3 minus 1, as shown in the graph below. Further guidance and information. If you have any further questions about algebra or would like to discuss any other aspects of mathematics, you can talk to your lecturer or personal advisor, or make an appointment to see a learning enhancement tutor in the Dean of Students office. You can telephone 01603 592761, email dos.help@uea.ac.uk, or visit our website at www.uea.ac.uk/dos/let. There are further resources on many other aspects of numeracy, mathematics, statistics and science available from the Dean of Students office and on its website. These include questions to practice, model solutions, and webcasts illustrating essential skills. This guidance is one of a series on mathematics produced by the Dean of Students Office at the University of East Anglia.